The Tully Monster got its name because of the collector who originally found the specimen. His name was Francis Tully, and he was an amateur fossil collector, and he was going out to the Maison Creek fossil site, and he found some Tully Monster fossils, and he was so puzzled by them and didn't understand what they were or how to identify them that he brought them to the Field Museum to Dr. Eugene Richardson, who was the paleontologist on staff at the Field Museum. However, he was also unable to identify what the Tully Monster was, so he colloquially referred to it as Tully's Monster, and that's how it got its name. Its scientific name is Tully Monstrum gregarium, so Tully Monstrum after Tully's monster, and then gregarium meaning fairly common. A Tully Monster is really different from a dinosaur in that it's entirely soft-bodied, so it has no bones on the inside of it, and it has features or a combination of features that we don't see in any other animal on Earth. So with dinosaurs, we're pretty certain they look like lizards, but with Tully Monster, it looks like a ton of different things. It looks like a fish, it looks like a snail, it looks like something like a worm, and so we can see that it's this weird creature that we don't even know what group it belongs to, what animal group. We find the Tully Monster millions of years before dinosaurs actually evolved. It's a really special fossil for Illinois because it's the only place in the whole world where we find those sorts of fossils.
The spot in Illinois where the Tully Monster was right on the edge of an ocean and a big terrestrial coal swamp. So half of Illinois was underwater, and half of it was like an equatorial, so a very warm, humid, tropical coal swamp with big trees and big ferns, but no flowers. This is before flowers evolved. No birds before birds evolved. No mammals, no dinosaurs. Lots of giant insects, lots of giant arthropods like giant millipedes, a lot of amphibians and fish living in this coal swamp. For using the synchrotron at Argonne will actually, I think, make it possible to interpret the fossils and determine what they're related to. And there's two ways we can do this. The first is looking at its morphological features. So what type of eyes does it have? What type of teeth does it have? What does its body look like? By using the various tomographic beams at Argonne that give you a 3D structural picture of the animal, we can interpret the morphology more accurately and therefore see what animal looks most like. Then the other thing is about the chemical structure of the fossil. So what chemicals is the fossil preserved and what elements are included in the fossil? Now this is determined by what type of animal it was and what part of the animal is being preserved. And you can see a little bit of that just by looking at the fossil and looking at the color changes. But by using the elemental mapping at Argonne, we'll be able to actually quantify this, which should give us a really good idea of what the tissues were like.
Without APS, the Tully Monster research would hit a dead end as any other projects that they have hit the same dead end. So using APS, I think it's going to give us a quantification of the results, so it's important.
We can't do these analyses at Yale. There are only a few places in the world that have these opportunities, and Argonne is one.
I think it'll be really exciting to see what the Tully Monster actually is.
So it's great because we bring this really powerful analytic technique to bear on these fossils that have been known for a very long time, and hopefully answering some really interesting questions